last video, we talked in detail about mechanical heat recovery ventilation systems. So now let's move on to describe positive pressure ventilation and cover how this is different to MHRV. The term HRV stands for heat recovery ventilation and should not be confused with company names or other systems that are not true heat recovery systems. Many ventilation systems are better described as positive pressure ventilation, PPVs. PPVs work by drawing the air stored in the ceiling and pushing it through ducts into the various rooms in a home. On sunny days, the air inside a roof space is generally drier and warmer than the air circulating inside the house. By pushing this warm air into your home, the system simultaneously forces out existing damp air, thereby reducing condensation. The slight positive pressure sustained within the house reduces the infiltration of environmental pollutants. Massey University research found a slight reduction of relative humidity in some houses where these systems were used, and resulting positive impacts on mould occurrence. However, moist interior air is typically forced out through cracks and gaps in a non-airtight building envelope, taking heat energy with it. Additionally, warm air forced into a cold wall cavity by positive pressure can also condense. This is called interstitial condensation and can cause mould to grow inside walls where it goes unnoticed. To avoid contributing to moisture buildup in building cavities, it has to try and balance the pressure and is sometimes combined with an intermittently running extraction fan or passive vents in kitchens or bathrooms. This removes moisture, but again it takes heat energy with it. Without a successful balance, room air may also get pushed into the attic where it is then recycled. And where older recessed downlights are present, this can create a shortcut where indoor air rises and migrates into the roof space to be pumped back into the house again and again. A drier home is a warmer home, but as the available warm air in the roof space is pushed into the house, it is replaced with cooler air from outside, which in turn is pushed into your home, reducing the temperature. For the PPV or a forced air system to continue to provide adequate warm air into your home, it needs to be heated, which requires further heating and energy costs. University of Otago research raised serious doubts regarding the suitability of positive pressure ventilation systems that utilises roof air for the provision of free heat. Arguably, the air in any roof space is neither fresh nor healthy, as it's generally full of dust mites and spores. To clean this air, the system needs to filter it prior to it being introduced into your home, and this may not be to the same extent as those introducing fresh air directly from outside. Regardless, the filter needs to be extremely good, so quality is again paramount and should be checked. Also, the cleaning of filters is essential, and the risks of forgetting to do this task over time is common where the filters are hidden away in the roof space. So, the two systems really have two separate purposes. PPV is specifically for ventilation where condensation is an issue, while MHRV is focused more on controlling your environment with regard to comfort, namely heating, cooling and air filtration. PPV can work very effectively for the management of internal condensation, but an understanding of the quality of air supply, filter quality and maintenance, and potential implications for the escape of heat in terms of comfort and related heating costs should be sought. In conclusion then, while ventilation systems have a critical role in providing acceptable indoor air quality, it needs to be part of a comprehensive design standard to be fully optimised and energy efficient. The design of your new home is a rare but amazing opportunity to address all these issues and create a high-performing and healthy home. To find out more about a better performing home, why not grab our free guide on the link below.